Hey guys, the next video that I'm going to link you guys into or share with you guys is actually a video that I recorded for my Chemistry 151 class or Gen Chem 1. As it turns out, you guys are learning the exact same information that they are learning. So instead of creating a whole new video, I'm just going to link you into their video. The video is going to show this slide right here. Well, this is not your chapter 1. The information for you is going to be found in chapter 7. So this is part of our chapter 7 chemical quantities section. But it's the exact same information. So I'm going to go ahead and link you guys into that video now. And you can listen to it and it'll be the same information. All right, so this is going to be the last video for chapter 1. So we're going to wrap up the chapter with this one. In the last video, we introduced ourselves to this idea of the counting number, the mole, and we introduced ourselves to Avogadro's number. So we could go from moles to atoms and atoms to moles. Cool. But we don't really have a way of counting individual atoms, and certainly not in our lab or with our lab kits. So what kind of things can we measure in the lab? What would be a useful measurement and then a useful conversion for us? So here are 3 things that we can measure in the lab. So this one down here in the bottom left, that's a pH meter. We'll relate that to this concept in general chemistry too, so the next semester. Here we see a series of graduated cylinders, so we certainly can measure volume, right? So in the coming chapters, we'll relate volume to this information. What we want to talk about today is this guy right here, the scale. So I can walk into the lab, I can throw something on this scale, and it's going to read a measurement in grams. It's going to read the mass of that. So it would be helpful if we could tie in this idea of mass to maybe moles or Avogadro's number. Good news is we can. So here is the concept of molar mass. The atomic mass in AMU of an element is numerically equal to the mass in grams of 1 mole of that element. That's a heavy statement with a lot of scientific mumbo jumbo. So let's break it down. Let's get to the heart of that. So the atomic mass in AMU. The atomic mass in AMU, I'm going to click forward real quick, is that number at the bottom of the periodic table. So the example that I have on the slide is sodium. So here's sodium, and I see that the atomic mass is 22.9. So that number on the periodic table is numerically equal to the mass in grams. So all that's saying is, you know what, this isn't atomic mass units, but now we're going to say 22.9 grams equals 1 mole of that element. Okay. Another way to state this. If I were to walk into my lab, grab my sodium off the shelf, go to the scale, I weigh out 22.9 grams of sodium. I just weighed out 1 mole of sodium. All right? So let's click ahead here. We can look at some together. Let's say I grab carbon off of the shelf. So I grab my jar of carbon, I walk over to the scale, I weigh out 12.011 grams of carbon. Well, I just weighed out 1 mole of carbon. If I want to weigh out 1 mole of iron, I want to weigh out 1 mole of iron. How much iron am I going to weigh out? I'm going to weigh out 55.845 grams. That's 1 mole of iron. So that's the idea of molar mass. We can write this in, shocker, inequality, right? That's what we've been doing. So in this equality, we have 1 mole equals X number of grams. Why is there the letter X here? Well, it depends on what we're dealing with, right? So if we're dealing with sodium, it's 22.9 grams. If we're dealing with carbon, it's 12.011 grams. So depending on what material we're dealing with, that'll determine what this number is here. So that's the wrinkle in this equality. But again, the problem's going to tell us what to do. If we have an equality, then certainly we can have a conversion factor. So mole on top, gram on bottom, gram on top, mole on bottom. Okay. So let's just knock out an example quickly together. So I want to know how many moles are in 22.5 gram sample of oxygen. So I walk over to the scale. I weigh out 22.5 grams of oxygen, and now I want to know how many moles that is. This is a unit conversion problem. I'm going from grams to moles. So what's the very first thing that I do for every unit conversion problem that ever existed in chemistry? I write down the measurement that was given. Yep, so 22.5 grams of oxygen. Draw my train tracks. What unit is going to go on the bottom? What's going to go diagonal? What are we getting rid of? Grams of oxygen. And then what unit is going to go on top? What's our destination? Moles. So moles of oxygen. Okay. Click back to our equality. What number is still attached to mole? Yeah, the number 1 is still attached to mole. So anywhere I see the unit mole, I'm still going to put a number 1. What number is attached to grams? Well, it depends on what we're dealing with. We're dealing with oxygen. So here's why it's handy to have that periodic table. So I find oxygen on the periodic table. I see that it has a molar mass of 15.999. So 15.999 is what is attached to grams. Okay. Multiply across the top, divide by the bottom. So 22.5 times 1 divided by 15.999 equals, calculator spits out 1.406337, yada, yada, yada. Is that the number that I'm going to report? Of course not. So 3 sig figs here. So when I report my answer, I can only report 3 sig figs. So 1.41 grams canceled, and that is moles of oxygen. Okay. So now we can go into the lab, weigh out some oxygen, determine how many moles that is. What if I wanted to do something silly, like weigh out some calcium, and I weigh out, 1.28 grams of calcium. And I want to know how many atoms of calcium are sitting on that scale. Well, how in the world would I do that? We've talked about grams to moles. We've talked about atoms to moles. But have we talked about going from grams to atoms yet? So straight from grams to atoms? No, we haven't. And we're not going to, because it doesn't exist. There's no direct route between those two. But what is the one unit that can connect those two things? We talked grams to moles. We talked atoms to moles. So if we want to figure this out, we just simply have to take a bypass, take a detour through moles to get to atoms. So I would go from grams to moles using the molar mass. then I would go moles to atoms using Avogadro's number. I highly recommend that you have this map sitting next to you as you're working through these problems and even on the exam. So it doesn't have to be this exact one. You can come up with one that works for your brain. But it's just nice to have a map next to you as you're trying to find your path through these problems. So the people that do the best on my exams are the one that heed this advice and have this near them while they're trying to work through stuff. Okay. All right, so let's do this problem. So calculate the number of atoms of calcium contained in 1.28 grams of calcium. So 1.28 grams, I'm up here in the blue box. And I eventually want to get here to the orange box, but I can't just go directly over to the orange box. I have to make a detour. So my first step is going to be grams to moles. And to do that, I'm going to use molar mass. So for every unit conversion problem that's ever existed in chemistry, ever, we first write down the information that's given. So 1.28 grams of calcium. Draw our train tracks. What unit is going to go on the bottom? What unit are we trying to get rid of? Grams of calcium. And what unit is going to go on the top? What's our first destination, our first stop? So here's where the map is helpful. So our first stop is moles. So we're going to do moles of calcium here. What unit always goes with mole? Yep, the number 1. And then how many grams of calcium are in 1 mole? Go to your periodic table. Find calcium. Finding it's half the problem, half the battle. So find calcium and 40.078. .078. Okay. Multiply across the top, divide by the bottom. So 1.28 times 1 divided by 40.078. And my calculator spits out. But I have to consider sig figs because I'm taking a pause in the problem here. So I see 3 sig figs. So I would only keep the 3, the 1, and the 9. And what's my unit? So grams cancels. I've got moles of calcium. Okay. Well, this problem is not asking about moles. This problem is asking about atoms. So we've made this first transition from grams to moles. So now we are here. We're in the green box. And we want to make this last step to the orange box. So I want to go from moles to things, or in this case, moles to atoms. So what I'm going to do is I'm going to take that information from the first problem, and I'm simply going to start a new train track. And I'm going to do it in a different color so it doesn't get too jumbled up here. So I'm going to take 0.0319 moles of calcium. Okay. And I'm just simply going to do another unit conversion. So what unit goes on the bottom? Well, now I'm trying to get rid of moles. What unit goes on the top? Well, I'm trying to get to atoms. So atoms of calcium up here. What am I going to use? What equality am I going to use to get from moles to atoms? Well, I'm going to use Avogadro's number. The number 1 always goes with mole. For now, we'll just make that easy for ourselves now. What is Avogadro's number? So what number goes with atoms? 6.022 times 10 to the 23rd. Okay. Multiply across the top, divide by the bottom. So I've got 0.0319 times 6.022 times 10 to the 23rd. And I get 1.921018 E22. So again, sig figs. 3 sig figs at the beginning, so I can only report 3 sig figs at the end. And then this E22, don't forget to add that as times 10 to the 22nd. You can write E22, that's fine, I don't mind, but just make sure you add that exponent piece. And this is atoms of calcium. And then the last thing that we want to do is we want to ask ourselves, does this make sense? We weighed out 1.28 grams of calcium. Would we expect that to be a ridiculously large number of atoms? Yeah, we would. Yep, we absolutely would. So this number does make sense. Likely I got the problem right. You are going to see these types of problems pretty much from now until December. So the name of the game here is practice, 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 practice. I'm going to get some helpful handouts up onto Blackboard to help you practice with this. There's certainly practice in Pearson, practice in Chem 101. You can also Google Avogadro's number, molar mass, and you'll get more worksheets with the answer keys than you have time to do. So certainly there's lots of opportunities to practice out there, and you've got to practice this skill to get good at it, and it's not going away. Okay? So I hope you guys found this helpful.